The PDB Reader is a required module whenever your builder workflow involves a protein structure. It provides the essential first step for preparing a protein or protein-ligand complex prior to system construction. In this demo, we introduce the advanced options of the PDB Reader. Since there are 14 options in total, which can be difficult to explain all at once, we will instead present examples to illustrate each option in detail. We have already demonstrated the basic usage of the PDB Reader in a previous session. Here we will begin from step 3 to highlight the advanced options. If you need instructions on the basic functions, please refer to the earlier demo first. In this case, we will load the 8DH1PDB, which contains the T7-RNA polymerase elongation complex bound to DNA and RNA with an unnatural base pair. After loading the PDB, the blue highlighted options are automatically activated. By default, 4 options are enabled, and we will additionally enable the mutation option manually. 1. Chain selection. The PDB file includes several protein chains, nucleic acids, a standalone ligand, and ion chains. In this case, we will focus on loading DNA and RNA. Among the proteins, we will choose Prot-A, and the corresponding nucleic acids will be DNA-A, RNA-A, and DNA-B. After selecting the proper options, you may also choose ions. However, in this case, we will deselect all ions. 2. Model missing residues. The PDB Reader can automatically generate missing residues in each protein, and most options are suitable by default. However, note that modeling more than 10 consecutive missing residues may result in an inaccurate structure. In this PDB, we can deselect residues 356 to 371 to avoid errors. When you deselect residues, the terminal capping options will appear. You can then choose from several capping options. In this case, we will use the default settings. Terminal capping is applied to stabilize the exposed N and C termini, preventing unrealistic charges and ensuring a more physiologically relevant structure. 3. Non-standard amino acid RNA substitution. If the PDB contains non-standard residues in DNA or RNA, this option will be activated by default. For residues that are not supported by PDB Reader, you must generate their force fields in the same way as a ligand. Note that force field generation is only supported for amino acids. In this case, the program will automatically generate and apply the force field parameters. Here, residue 91N should be swapped with the proper nucleotide. You can either select from the drop-down menu or click the search button. We will choose adenine. After checking the structure, click Apply. 4. Terminal cappings. In this option, terminal capping is applied by default. If you want to generate a cyclic peptide or protein, you must select cyclization. In this case, however, you may choose neutral caps, charged caps, or apply custom caps depending on your modeling needs or the force field requirements. Here, we will keep the default selection. After setting all the options and clicking Submit, the generation begins. This process takes some time. Once the generation is complete, the RNA is created and can be properly recognized in the PDB. This PDB can then be used for various studies such as MD simulations or free energy calculations.